Hello everyone, welcome back. So in this video we're going to learn more about indexing with NumPy arrays. And so as always we are going to start with what we always do by importing NumPy as NP. Alrighty, now let's to try things out and let's create a NumPy array using the tools we saw last time. A equals A range 1R. And let's take a look at A. And I forgot the NP. There we go. Was focusing on the double R and I forgot the NP dot. All right. So indexing for NumPy arrays basically works the same way as it does for lists and for strings. So we can go ahead and we can print A0, A3, and let's see what the last one will be, A9. Or let's go with an A-1 to get the last element of the array. And so conveniently we've set it up so that, for example, A3 is equal to 3. And we can also get the first 4 elements by typing A0 colon 4. So far this is exactly like the way it works with lists. Now we can start getting a little wilder. Something you can do with a NumPy array is you can use a list as an index, and this is very common. So let's have a list containing elements 4, 5, and 8. Then if we type of A of L, this is going to print the 4th, 5th, and 8th entry of the array, which happen to be the numbers 4, 5, and 8 because of the way we set things up. We also note that Boolean logic acts bitwise, which means if I type A modulus 2 is equal to 1, then it's going to be false, true, false, true, false, true, false, true, false, true, because our numbers were 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so they go true, false, true, false, true. They go even, odd, even, odd, even, odd, even, odd. So we get false, true, false, true, false, true, false, true. So what we can do is we can use this to look at the entries where this is true. So we say A such that, well, this is a list-like object, so we put that inside. And this is going to only print the odd elements of A. So a way to think about this is to think of A modulus 2 as a mask. So mask is equal to, I'm just going to put it in parentheses, A modulus 2 equal 1. And what we're doing is we're putting the elements of A where the mask is true. Another thing we can do is we can compare arrays pointwise. So here I'm going to create a random array of ints. So we're going to say B is equal to np.random.randint 0, 10, and 10. So this is going to give us 10 random integers between 0 and 10. And we can then print out that A greater than B. This is going to give us some falses, some trues. And then we can print the elements of A where this is true by saying mask is equal to A greater than B, and then print out A of mask. And that'll give us the 3rd, 6th, and 9th element, which those are the elements of A which turned out to be bigger than the randomly generated events. Note this is random, so if we rerun the same code, we actually get something different. Now we can combine this if we want to make multiple conditions on the same side by using and or. And here and or are going to be a little bit different, meaning you're going to use the bitwise and symbol, which is the and sign, ampersand, and the vertical pipe symbol for or, because this is going to have to act bitwise. So to test this out, let's make mask 1 be A greater than 5 and A modulus 2 equals 1. So we could see mask 1 looks like that. And if we do A of mask 1, we get 7 and 9, because those are the odd entries which are greater than 5. Conversely, if we wanted to use OR, we could do almost exactly the same thing. Let's call this mask 2. But rather than the and sign symbol, we would use a vertical pipe. And now we get all the entries which are greater than 5 or odd. Alrighty. Now let's move on to see how we can modify the entries in an array. And modifying a single entry is relatively straightforward. So let's have A, same as before. It'd be np.arange 10. A looks like that. And if we want to set entry 5 to be equal to 50, we just do it. Now let's look at A. We can also do this with Boolean indexing. So let's say our mask is equal to A modulus 2 is equal to 1. Now let's just set all of those entries where the mask is true to be equal to 7. Now let's take a look at it. Okay, we changed all of the odd entries to 7. Another nifty thing we can do is we can change entire blocks at a time. So if we want to change this block of starting at 2 up to but not including 5 to be equal to 1, 2, 3, we can do that. And now this block here is equal to 1, 2, 3. And you know what we can do? We can even do this. A such that A is equal to 7. Okay, so this is the block. Right now we have 3 7s in our list. So we can set A such that A is equal to 7 equal to 111, 222, and 333. And that's going to change this 7 to a 111. This 7 is going to get changed to a 222, and this to a 333. When you're doing stuff like this, though, you do have to be a little bit careful. So for instance, right now there are 3 elements which are greater than 100, so this works fine. So that's fine, but if you do either of these, this will throw an error because the sizes don't match. Error. And if it was too big, we'd also get an error. All right. Now I'm just going to hide this because I don't like errors. Errors hurt my brain. Now what's kind of surprising is this actually is going to work. So we saw this worked fine because it's the right size. We saw that having only 2 was too small and 4 is only too big. So what if we only had 1? Now let's avoid 666. That's the devil's number. I'm filming this right around Christmas season. We don't need the devil's number like right around the Christmas season. Alrighty, let's go with 777. Much better. Miraculously, that worked. And this is because of something that is magical called broadcasting, which you'll learn more about later. Now, moving on to 2D arrays. Let's look at how the indexing works for 2D arrays. So let's let A be A range 15, but its A range is a function from the Numpy module. And A is equal to A dot reshape 3, 5. And let's take a look at it. So we want to get the first index is going to be rows and the second index is columns. In other words, if we type in A of 0, comma 1, this is going to give us an entry from row 0, column 1, which is going to be a 1. Or okay, let's be consistent with the notes, sorry. This will give us row 1, column 3. And so we get an 8 because we go row index 1 is the second row, column 3 is the fourth column, so we get an 8. We can also do negative indexing. So we want to go last row, second last column. We do that. And something we like sometimes, sorry, a little bit of a tongue twister there. Something we sometimes like to do is to print entire rows or columns at the same time. So to print the entire first row, we do A, 0, comma, colon. And to print the entire first column, it's the same thing, but the other way around. So it's colon, comma, 0. And you can actually get all of A in kind of a silly manner just by doing colon, colon with a comma in the middle. And again, for 2D arrays, we can still use masks. So if we have mask is equal to A modulus 2 equals 1, then A of mask is actually already going to just give us, it's going to give us a 1D array with all of the odd entries. So when you use masking, it does reshape everything back into a 1D array, and it kind of needs to, because there really wouldn't be a good workaround otherwise. Otherwise, it would get weird. But what we can do is we can say that A of mask plus equals 2. And now look at A, and we see that we've added 2 to all of our odd entries. So this is where I'm going to stop for this video. I will see you guys again next time.